Welcome to this tutorial where I'll be going through the section B part of the chemistry 2025 question paper for internal candidates. By the grace of Jesus, I'll be able to go through these questions. Okay, all right. Let's start with the first question, which says the following diagram shows apparatus that can be used to electrolyze concentrated aqueous sodium chloride. So here it should be known that concentrated aqueous sodium chloride is at times referred to as brine. So instead of saying concentrated aqueous sodium chloride, other books would prefer saying brine. Alright, it's one and the same thing. Then the first question says the electrolyte contains sodium ions and chloride ions. Write the formula of the other two ions in the electrolyte. Okay. Since the information from the question has explicitly told us that aqueous sodium chloride, and we know that aqueous means that there is water present. So in this electrolyte here, we have water. So what will happen here is that when there is a discharge of electricity, both the sodium chloride and the water will decompose because they are electrolytes. So we already told that the sodium chloride decomposes to these ions. But if there is a surge of electricity, then the water will also decompose to form hydroxide ions and hydrogen ions. So this is a formula of the other two ions in the electrolyte. Okay, question B. Construct equations for the reactions at the number 1 are cathode and number 2 anode. Okay, alright. So we have the cathode here and the anode here. Okay, right. So we have already established that the electrolyte contains a total of 4 ions. So we can group them into positive ions and negative ions. Okay, so the positive ions are sodium and and hydrogen ion, whereas the negative ions are the hydroxide as well as the chloride ions. Now, as the process of electrolysis occurs, only one of these ions will be discharged at their respective electrode. Okay, now to determine the ion, let's start with the positive ions, okay, which we can as well refer to as the cation. So to determine the cation that would be discharged at its respective electrode, then we should follow the rule that says that the cation that is discharged is the one that is least reactive. So between these two, between sodium and hydrogen, which one is less reactive? It's surely the hydrogen. So we expect hydrogen to be discharged. Okay. So since the cations are positively charged, they would migrate to the negative terminal of the power supply, which is the cathode. Okay. So here we expect hydrogen to be discharged at the cathode. Right. And we know that at the cathode, a type of reaction that occurs is what we call a reduction reaction, meaning that the hydrogen will gain electrons. Right. So what will happen is this. So we have this formula. We have this equation for the reaction occurring at the cathode. Okay, so this is gas. Right, so I've already answered the first part of the question. Then the second part of the question says we also write the formula, or rather the equation, at the anode. Okay, so we have to apply the same rule here, but with a bit of a trick. So we have the anions, which are the chlorine ions, as well as the hydroxide ion. Okay, all right. So here the twist is that the question has said concentrated aqueous sodium chloride. So once you hear this word here, concentrated, it applies to anions. So here the rule that will follow is that the anion that is in a higher concentration will be discharged at its respective electrode. Okay, so the question says concentrated sodium chloride, meaning that the chloride is in a higher concentration. Thus, at the anode, we expect chlorine to be discharged since it is in a higher concentration. And we know the type of reaction that occurs at the anode is what we call an oxidation reaction, and this type of reaction is characterized by a chemical species losing electrons. So we expect the chlorine to lose electrons All right, let me write it properly. Okay, so we expect the chlorine to lose 2 electrons like this. So this is the reaction that is occurring at the anode. So this is aqueous and this is gas here. All right. Then the third part of the equation says, suggest why the concentration of sodium hydroxide in the electrolyte increases as the electrolysis proceeds. Okay. So why does the concentration of sodium hydroxide increase here? This is very easy because we have answered most part of the equation, so it would not be very challenging for us to explain why. Okay, so as we have observed, at the anode, chlorine gas is discharged. Okay, and at the cathode, um, hydrogen gas is discharged. So if the electrolyte, which had a total of 4 ions, and these are this let me quickly write them down. Okay, so this is sodium and this is hydrogen. Okay, so if the electrolyte, which had a total of about 4 ions, loses 2 ions, which are the hydrogen and the chlorine, then surely the concentration of the sodium hydroxide will increase. Why? Because as the electrolysis process proceeds, hydrogen gas and chlorine gas are discharged at their respective electrode, thereby leaving behind sodium ions and hydroxide ions in a higher concentration. Okay, so I think that would be the answer. Question D. State the chemical test of the product at the anode and state one of its uses. So here we have already established to say that at the anode we have chlorine gas here. So we have chlorine gas. And the test for chlorine gas is that it turns moist blue litmus paper, let me just call it LP, red, and bleaches it. All right, and bleaches it. So if the substance at the anode here does this, then it's surely chlorine gas. And the reason why it's able to turn a moist blue litmus paper to red is because chlorine gas is acidic in nature. All right. Then the second part of the question says to state one of its uses. So one of the uses of chlorine gas is that it is used in sterilizing drinking water, because chlorine gas is able to kill microorganisms such as bacteria, thereby ensuring that the water is safe for drinking. Okay, then the question E. In another experiment, 4.6 kg of sodium metal was produced by electrolyzing molten sodium chloride. Calculate the volume of chlorine gas produced at the same time at room temperature and pressure, given the following overall equation. Alright. Okay. So the procedure that we'll use here is that we'll first find the number of moles of sodium, then compare the stoichiometric ratio so that we find the number of moles of chlorine. Then upon doing that, we'll use the relationship that exists between the number of moles and the volume of a gas to and the volume of a gas at room temperature in order to find the volume of chlorine gas. So let me start what I mean. So like I said, at first we will find the number of moles of sodium. Remember, number of moles denoted by N of sodium is equal to mass over the molar mass. The mass of sodium we're given from the question, it's 4.6 kg. But in chemistry, the units of mass that are used are grams. So we should multiply 4.6 by 1000 so that we get our mass in grams over the molar mass of sodium metal, which is 23. Doing so will give me number of moles as being equal to 200 moles. Alright. So we're done with the first part. Then the second part is where we compare the stoichiometric ratios of the products so that we find the number of moles of chlorine gas. So what we have is that Na over chlorine is equal to 2 over 1 because the stoichiometric ratio of sodium is 2 and the stoichiometric ratio of chlorine gas is 1. Alright, so number of moles of sodium is 200, so you can replace 200 there over here, let me just call it chlorine gas there, over 2 over 1 there. So if I do my basic math here, I'm getting the value of number of moles of chlorine gas as being equal to 100 moles. So we have 100 moles here. And we know the relationship that exists between volume and number of moles of a gas at room temperature and pressure is that 1 mole of a gas is equal to 24 decimeter cube. Okay, so if we have 100 moles of a gas, it will equal to, we'll call it X. X here represents the volume of the chlorine gas. So if we do the math there, we'll find that X is equal to 2400 decimeter cube, meaning that the volume of chlorine gas is 2400 decimeter cube. Alright. Then this question 10, I remember I solved this in another video, so you can get the video to watch the solutions. Otherwise, let's go to this organic chemistry question. Question B11. The following are the displayed structures of some organic compounds. Choose the compound or compounds from the given list to answer the following questions. The compounds may be chosen once, more than once, or not at all. Alright, the A part says which two compounds can react together to form an ester and name the ester formed. Alright, so here we should know that the so-called esters are formed from a reaction called an esterification reaction. Okay, so this is a reaction between an acid, to be specific, a carboxylic acid plus an alcohol. So you find that when they react together, they form ester. They form an ester plus water. Okay, so here the two compounds that we should identify the carboxylic acid. One should be a carboxylic acid and the other should be an alcohol. From what I can see here, the alcohol is C, because alcohols are characterized by the presence of this hydroxide functional group. So the one having this hydroxide functional group is C. Therefore, C is my alcohol. Then the carboxylic acid, it is this one, it is D. Why? Because carboxylic acid are also identified by the presence of this functional group called the carboxyl functional group. So once you see an organic compound attached with this functional group, then that organic compound is a carboxylic acid. So here the two compounds which can react to form an ester are C and D. Alright, but we're not done. We are told to name the ester formed. Okay. Alright. So, in naming the ester formed, we should first give names to these organic compounds that we have identified. So, having said that C is an alcohol, the name of this alcohol will be, let's start with a prefix. So the prefix will be eth. Why? Because this alcohol has two carbon atoms, and remember, alcohols end with the suffix ano. Alright, so its name will be ethano. So that's the name of C. Then for D, this carboxylic acid has one carbon atom, so it starts with a prefix meth. Okay, then for carboxylic acids, they are named as methanoic acid. So they have this anoic here. This one here, that's the suffix of carboxylic acids. Alright. Okay. So in drawing, we're taught to give name, right? Okay. In naming the ester formed, we should first start with the name of the alcohol. But we are not going to write it the way it is as ethanol, but instead it will be ethyl. Why? Because the ethanol, this ano here, is replaced with this U here coming from the alkyl group. So its name will be ethyl. Then the name of the acid, we're not just going to write it as methanoic acid, but instead we'll call it methanoid. So methanoid. So this anoic and other stuff is substituted with anode. So its name will be ethyl methanoid. Okay. Question B, which compound is the least reactive? So here the least reactive compound should be an alkane. Why? Because alkanes are characterized by the presence of single carbon to carbon bonds, and they do not have a functional group. So they do not have a functional group. As a result, alkanes are generally unreactive because there is no position where other atoms can attach. Alright, so here in identifying the compound, we should just locate the compound having single carbon to carbon bonds. That's that's compound A. Okay, so the answer here is compound A. Then question 2, draw the structure of the polymer formed by compound B, showing only 3 repeating units. So where is compound B? Compound B is here. And compound B is an alkene. Why? Because alkenes have a presence of a double bond. So before we even draw the structure of this polymer, as the question has specified, we should first name this alkene that we have identified. So the name of this alkene, since it has 1, 2, 3 carbon atoms, its prefix will be prop. Okay, and we should remember that all alkenes end with "in", so its name is propene, right? Okay, so propene will undergo a type of polymerization called additional polymerization, where this double carbon to carbon bond will be broken so that other atoms can get attached to it, right? So what we'll have is this. First, let me draw the condensed formula of this propene here. So okay, so we'll have that. All right, so CH3, and that's an H, that's an H, and two remaining an H there on top. Okay, so this is a condensed formula of propene, and remember propene is going to be my monomer. Okay, so we're told to draw 3 repeating units, so we'll generally have this. Then all right, I made a mistake of writing the double bond, I'm really sorry. Okay, so this is 1. All right, so have 1, 2 and 3. Okay, so let's complete this structure. Okay, so CH3, then the rest are just hydrogens, so the rest are hydrogens. Hydrogen there, hydrogen there, hydrogen there, hydrogen there, hydrogen here, and hydrogen there. So this is the structure of this polymer formed by compound B. All right. And number 3, name the compound which would rapidly decolorize bromine water. So the organic compound with such a characteristic is called an alkene, and it is compound B. Why? Because when alkenes react with the bromine that is present in the bromine water, a type of reaction called halogenation occurs, whereby the bromine atoms are attached to this to the ends of this alkene here, resulting in this double carbon to carbon bond breaking. So when this happens, we are told that bromine water, right? So the water loses the bromine. So once it loses the bromine, which is reddish brown in color, the water will become decolorized. So here, the organic compound that does this is option B. All right. Question B. The structures of two polymers are shown. Number 1, between X and Y, give two similarities. Okay. So if we can, the structures of the two polymers are shown. Between X and Y, A give two similarities. So as we can observe, both X and Y are made from smaller repeating units called monomers. So we can observe these repeating units. Even here we have, if I were like to separate, so I had have this part and that part. Okay, so here one similarity that we can give is that they are both made from smaller repeating units called monomers. Alright, then the other similarity that we can give is that they are both synthetic polymers, meaning that they are both man-made polymers. Then for the differences that we can give here is that polymer X is formed by additional polymerization, while polymer Y is formed from condensation polymerization. Then another difference that we can give, since there are two differences, the other difference that we can give is that in polymer X, the monomers are the same. So you can observe here, the monomers are the same. But for polymer Y, two different monomers are used. So we have this monomer and that other monomer. So for polymer Y, two different monomers are used. Okay. Then question B2, what is the best way of disposing of these polymers? Right. So we can give here by disposing them in what we call recycle bins. Okay. Alright.